Welcome back, guys. All I really have time for this weekend is a simple kit build. So that's what I'm looking to do today. And we had a wedding in the family and took up a lot of my time. So not only am I late with this video, but I'm going to have to make it a simple one. And I think, okay, so this one is, this kit here is one of the IC station kits. I have a list of those in here somewhere. Here we go. So we can determine what this one is. This one is 4151. And there we go, 4151. DC to DC step up module boost converter power supply blah 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 blah. Okay, so let's build this one up and have some fun today. All right, we got our iron is all heated up. Pads bat. Scope ring doesn't need to be here. My flesh cutters. So just to open up the bag and see what's inside. All right. That looks like a pretty simple kit. So it doesn't look like this is going to take very long. I'm going to need my magnifying glass to read those components. And this is based on a 34063 API chip. I wonder what happens if I punch that into Google. Just 1 second here. Okay, so that appears to be a 1.5 amp boost buck inverting switching regulator. May have a schematic up on the website, and that might help a lot. So I'm going to get that up on my screen over here. I also have a parts list here. So we're supposed to have one 5mm LED, one 1N5819 diode, and that's that. One 150 microhenry inductor, and that's that. Two of these connectors, the IC and its socket. And we're supposed to have two ceramic capacitors that are 104s. And I think yeah, that's a 104. That's a 104. And one ceramic capacitor that is a 101. And that is a 101. Okay. Next to the list, electrolytic capacitor 47 UF. And 47 UF, distinctly no name brand. Now just the resistors. So we need a 200 ohm resistor. I have to get them across here like this so I know where they are. That is not, that one is 4.7K. And here is a 1 ohm. So 1 ohm. This one here is a 100 ohm. Oh, definitely not. No, that's the other way around. That's what I love about these metal film resistors. This is our 200 ohm resistor. And here we have brown, black, black, red. So that would be a 10K. This one here, the brown, brown, black, red. They're not listing here, or oh no, that's the other way around again. So that's a brown, red, black, brown, which is a 1.2K. So if I put that,
I don't know that.
Alexa, shut up. And 4.7K. So we got, there we go, there are resistors. And we can start the assembly. They call this a seat. I call them sockets, but they call it a seat. So we'll start by putting in the resistors, the inductor, and the diode. Then we'll go up to the small ceramics. Then I'll probably move on to these components here, then the IC socket, and then these connectors, and that'll be it. All right, so unless something interesting happens, I'll get started on this and I'll meet you at the end. So something interesting did happen. I think I misidentified at least one of these metal film resistors, so I'm going to incorporate the help of our cheap kit meter here. So okay, I didn't misidentify it, so it is the 10K resistor, and I'll just carry on. Straighter on there. Yeah, that'll do. Not perfect, but then neither am I. Okay, so that's the input and that's the output. So theoretically, put 5 volts in here, we should be getting 12 volts out here. Okay, so let's get some little leads hooked up to this. Okay, we're all set up here. We have our beginner's power supply over here, our beginner's meter here. And up here there's a little DC load, which I'll show you in a second. Here we can see the power supply is all set up and ready to plug it in at 5 volts. So I'm just going to turn off the power right now on that and plug this in here. And that goes over to our board on the input here, and the output here we have coming up to this little DC load that I made a couple of years ago. It's just made up out of a module and a power supply inside this case, and then I arranged for 4-wire, 2-wire operation. We're in 2-wire mode, and I have set it up for a maximum current of 50 milliamps, which is this is rated at a maximum of 60 milliamps. I don't know why. Texas Instruments say the chip is good for 1.5 amps, but these guys, it says 60 milliamps, so 60 milliamps will do. And okay, and right here this meter comes down off the load here, so parallel there, and it comes down into the meter, and we're all set to ready DC volts. And let's turn it on and see what happens. Okay, well, it looks like we're getting 11.67 volts. The load is saying 11.62 volts, and we don't have it loaded down yet. So let's now switch on the load. So okay, with the 50 milliamp load on it, we see we drop down to 11.53 volts on here. So we are losing a little bit, and but you know, it is working properly as a boost converter in this case. If you see here, we're getting 11.5 volts at 49 milliamps, and then here we're putting out 5 volts at 20 milliamps. So it's giving us the efficiency that we expect from a boost converter. All right, guys, thanks a lot. We'll see you in the next one. Bye bye.